Welcome to Dean on the Scene, a WPI podcast. Today we're doing things a little differently. Instead of sitting down in a sound studio, we're stepping out onto campus for a conversation with Dan Linzell, Worcester Polytechnic Institute's new Bernard M. Gordon Dean of Engineering. As we move through campus, we'll see WPI through Dean Linzell's eyes. What stands out to him as an engineering leader, what excites him about the culture he's stepped into, and how students are putting ideas into action in real time. Whether you're part of the WPI community or discovering it for the first time, this episode is an invitation to listen, explore, and understand what happens when engineering education is rooted in collaboration and impact. So join us on the scene with Dean Dan Linzell. We're starting in the dean's office to get to know Dan Linzell beyond the title and what shaped his path to WPI, from the classroom to the lab and all the way to Washington, D.C., where he has played a national role guiding engineering research with the National Science Foundation. Dean Linzell, thank you so much for taking time out of your busy schedule as a relatively new dean here at WPI to sit down with us. We wanted to get to know a little bit about you and what you bring to WPI and our community.
Sure. I made a conscious decision many years ago to leave industry and go back to school to get the degrees that are needed to become a professor, so to join academia and enhance minds as they relate to engineering. I haven't looked back since. After making the decision to go back to graduate school, I was fortunate enough to get a position at Penn State University and grow up as an academic there. Made a conscious decision to go into administration. After 14 years at Penn State, I ended up at University of Nebraska-Lincoln and then spent some time at the National Science Foundation. Here I am. So I just see this position at this institution kind of a culmination of my desire to always want to be hopefully teaching others, hopefully helping others learn more about what their passion is.
Did you have a light bulb moment when you were in industry saying, I want to be able to take my knowledge and bring up the future technologists, engineers?
Yeah, I did. I had an opportunity as an undergraduate student to do research, and I did it, and it was great, but I chose to take a job, which certainly many students do today, and they have done forever, and enjoyed the job, but after, 3.5 years, I realized that I was missing, again, this different type of energy that exists on a college campus at WPI that I don't think you get that in industry, which again is all the excitement that is wrapped around with discovery. Again, I'm sitting here and I can't believe that I'm sitting here as Dean of the School of Engineering at WPI. I just feel incredibly honored to be able to say that.
Well, we're glad that your pathway has led you here. What was it about WPI that drew you to be sitting in this room and in this position?
Yeah, so when I was in high school, my late father, who was a mechanical engineer, interesting cat, loved him dearly, he would just bring up out of the blue institutions he thought were good engineering schools. And WPI came up. So it stuck in my head. And then I had other touch points with the institute as I was going through graduate school and through my academic life as a professor and all that good stuff. There was a faculty member at the institution I did graduate work at, Georgia Tech, who ended up coming to WPI a number of years ago, so I paid more attention to WPI as a result. I had people who were collaborating with people from WPI at both institutions that I worked at. When I was at NSF, I was certainly aware of a lot of the great research that was being sponsored by NSF through WPI. So I've known about the institution for a long time, and when I was approached about this position, that history came to mind, and when I started looking into WPI and the history, especially around PBL, around project-based learning, and that was something I've known about for a while too, in association with this particular institution and its ethos, I got more intrigued and more intrigued. And as I prepared for the interview, when you looked at things, when you looked at the products that students were producing, you could see the effects of project-based learning on the quality of those projects and the students' ability to be able to address unanswered problems and do so in a fashion that is clearly team-based,
Yep.
right? And that impressed me. And so this place is distinctive. The Institute knows who they are, and that's rare. And the more I looked, the more excited I got. I obviously applied, and here I sit. And again, I feel very lucky. I really do.
That's great. You mentioned the NSF. So you've overseen a $225 million national research portfolio focusing on infrastructure resilience, robotics, advanced manufacturing, materials innovation. How has that perspective shaped your work or will shape your work here at WPI?
Yeah, it was an honor to be able to do that, to be able to spend time at the National Science Foundation as what's known as a division director. And being able to direct, it's called the Division of Civil and Mechanical Manufacturing Innovation, was honestly, it's probably one of the best things I've ever done. I learned so much in such a short period of time about fields that I never thought I would learn anything about. And that has helped me better understand what the value propositions are. And I hate to say value propositions in association with basic/fundamental research,
Yep.
but they're different in different areas of engineering. And so I learned a lot about how important it would be for somebody to not only be funded for basic research at NSF, but also then to dovetail that research into a potential IUCRC, which WPI has a number of,
Yes.
industry university cooperative research centers, potentially dovetail that into something that involves one of the Manufacturing USA Institutes.
Mm-hmm.
So I understood better, again, motivation as well as what could lead to additional impact. I'm hoping to bring that here. I learned a lot about how NSF not only works behind the scenes, right? But also how that agency would interface with other agencies to support great things. There's a lot of activity that happens within NSF and between NSF and, let's say, NIST or DOE, Department of Energy, to, again, take the limited amount of money and get the maximum amount of effort, impact, discovery. WPI is very highly respected by federal funding agencies, and federal funding is always going to exist. It's not going to go away for important research that addresses important problems.
That understanding is so important across the board, especially in academia. Kind of leads into my next question about the interdisciplinary research done here. We're not siloed. You're Dean of Engineering, but so much can bleed into arts and sciences, the business school, et cetera. So how can students and our faculty members take advantage of that and continue to work within the whole ecosystem?
We build this foundation via the project-based learning that is focused on discovery, that serves the students wherever they go. We can leverage that as an institution. We can leverage those amazing minds that we have helped cultivate to potentially continue to do great research and help support and increase the visibility of WPI. And I think that's incredibly important.
What does engineering education need to look like in the next decade?
We have to figure out how AI becomes a beneficial part of the educational process. I can see where AI can be used to further a student's ability to think innovatively. How higher education could be structured in the future, I'm talking across the country, I would envision where you would have a kind of a setup where the teaching mission is as important, if not more important, than the research mission, at the very least as important, and we do that here.
Yes,
right?
we do.
Because all of this is scholarship. It's all teaching, learning, service, the staff support, it all goes to scholarship. And so being able to have the teaching mission be better intertwined with research activities, I think is something that will have to happen. I think that can happen in a project-based environment. So what can happen is, what if a project team has one team member who is a bot, right? So that team member is integrated into the activities and is someone who contributes to addressing the problem. How would students work with that bot, right? How would they work with that bot as a team? How would they all be reassured that what information that particular air quoting person provides is real and right and feasible? And this requires some really reverse engineering in association with that tool being utilized as a member of the team. I think that has to happen.
Yeah.
Right? That fits with WPI. Right? So we can't ignore the technology. It will come into what we do. But on the flip side, it's still important to be able to do stuff with your hands. Still important to be able to do things that can't be done, obviously, via AI, like being able to set up experiments and be able to do tests, being able to interpret data and really have it work through your knowledge base, your expertise to interpret things. But that still fits with this having a team member maybe be a bot, right? That kind of approach. So those are some of my thoughts. There's a lot of change that's happened and a lot of change that's coming over the centuries. There's been changes that have hit higher education. We've been able to adjust and still deliver what is needed. And I firmly believe we will and are adjusting to be able to deliver what is needed.
Thank you for bringing that up.
Yeah, sure.
This episode is Dean on the Scene, so I say we hit the road, head over to Caven Hall, which is the home of our civil architectural and environmental engineering, someplace that I think you feel at home.
Yes.
And let's talk a little bit about our labs, teaching, and the future of research.
Okay, let's go. High five.
All right, we made our way over to Caven Hall. As we're walking down to take a look at some of the labs that are housed here, can you talk a little bit about your area of expertise?
Sure, be happy to. I'm a structural engineer by training, and more specifically, most of the research I've been involved with has focused on bridges and how to better design bridges so that they last longer, more efficiently utilizing materials, and using innovative ways and innovative tools to help ensure that the designs are accurate. Most recently, our focus has been on what's called structural health monitoring, which is how do you utilize AI in conjunction with data that is taken from bridges or other types of infrastructure to determine how sick they are, and then determine how to make them well again. We've also just quickly focused on how to make infrastructure more resilient against extreme events. So mostly events that are man-made. So how do we make this building more resilient against a potential attack so that obviously the occupants are safe, and they at the very least have time to get out of the building before something really bad happens.
As we're standing in the bottom floor of Caven Hall, we're looking at what could be called a dirty lab.
What we're looking at is a lot of research that focuses on concretes and asphalt, and then the combination thereof as things age, not just the structures, the infrastructure, but also the materials. You need to better understand how they will react with one another over time, and how does that affect the durability and the strength of concrete. Another big piece to the research that is essential is better understanding of the chemistry involved so that you can potentially optimize how concrete will behave in the future, but also the geographic influence on stuff. Then you need to be able to better predict what it will become over time. And there's still a lot of work that needs to be done in that area specifically. And even more importantly, in my opinion, there's certainly a desire to make materials that are used to build infrastructure greener, per se.
Is AI, or has AI been a game changer in this field?
So in association with the work that I do and the work that I'm certainly aware of, yes, but it needs to be used responsibly and it needs to be based upon actual data. So this again is why we're standing in the dirty part of engineering, maybe, a dirty lab. I mean, there's other dirty labs, but civil engineering labs can be at the top of the dirty list. And actually this lab is remarkably clean compared to other labs I've been in. But we got to have the actual data. AI is more than ChatGPT. AI is a litany of algorithms that are put together to determine that, okay, if I have real data from concrete mix A and real data from concrete mix B, can I predict what will happen with concrete mix C without having to actually do tests, without having to get dirtier? And so for that all to work, you got to have reliable data for A and B, and that's why we're standing in a dirty lab.
Right. You still got to do the work.
Still got to do the work.
All right. So again, our listeners aren't seeing this. They can certainly go on our website and take a look at the photos we have. But what are some key pieces of apparatus?
So what we're looking at in Cave-In, there's a newer frame and an older frame. They're both essential to being able to understand how not only, let's say, pieces of a structure behave, so a single beam or a single column, but also how assemblages of pieces behave. So let's say in relation to some of the work my group has done, focusing on bridges, we could put in a relatively small but somewhat realistic model of a bridge superstructure system, which is the beams and the deck that you drive across, and get a better idea of how those things interact. One of the universal testing frames that we're looking at is called a servo-controlled UTF. So there's a servo valve. A servo valve is a very precise valve that is used to measure very accurately not only what is being put into these things that you're testing, which is load, but also how they respond. And so you can control what's going on and not have the thing that you're testing fall apart before you want it to or create a safety hazard. The other universal testing frame is called a screw type frame. It's got dig threaded shafts, and so it can load things very precisely as well. It's less likely to have things fail because it's a traditional kind of mechanical frame system, but it's harder to understand how something is responding to the load and react quickly with a screw type universal testing frame as opposed to a servo controlled universal testing frame. So enough about UTFs. I've talked way too long about universal testing frames. So anyways, in relation to my work, these are very valuable. A lot of my group's work, we take information from the lab and then we go out in the field and we test actual structures, and we're trying to correlate what goes on between the lab and a bridge that is sitting somewhere in Massachusetts, so that we don't have to go out and test every bridge. We don't necessarily have to even utilize the lab data, but again, we can utilize AI and virtual representations of the physical world to determine what's going on.
Absolutely. Let's cross over the hallway here, see if we can pop into another lab. Just a few doors down from structural engineering is an environmental engineering workspace, where we found 2 students working on their major qualifying project. And big surprise for them, Daniel Linzell wanted to check it out.
What's your names, guys?
I'm Gareth.
I'm Nathan.
So we're, for our MQP project, doing biochar hydrogel beads. The purpose is water remediation. Biochar is kind of like an ash. You get it by burning biomass in an oxygen absent environment. And so you get something like this, a char powder. Then we put it into a hydrogel, which is sodium alginate, which is made of seaweed. And we cross-link it with calcium, so we get these beads. And then we put it in the water with the dye, which in this case was like a textile dye. And then we're measuring the change in the absorbance of the dye to see if it's absorbing the contaminant.
So the intention is materials to clean up water. Yeah.
Yeah.
Thank you.
Yeah, that was great. It's really amazing that we're just crossed over the hallway from the structural engineering over to this area.
So dry to wet.
Dry to wet.
Dry to wet, yeah. And obviously these 2 young men, I'm going to call you young men because I'm a lot like older than your parents probably. They clearly, in my opinion, exemplify what WPI is and does, which we're having undergraduate students, seniors who are doing graduate level research, really. And I don't know if you guys know that, but you are. And that's something that will benefit you. Even if it's just a project that you needed, you will come back to this, I guarantee it. And you will remember the work that you did, and I'll help you later on. So thank you for letting us barge in.
So we are now going to take this tour across campus down to Gateway Park, where we have our world famous, I'll call it that, fire protection engineering lab. We made it over to Gateway Park, home of a lot of biotech and life science labs, and our fire protection engineering department. First question as we're walking in, does it surprise you that so many people drive by this building every day and not realize what's inside?
Yeah, it is pretty amazing because not only all the other activities that you mentioned, but specific to fire protection, this is one of very few programs, and in my opinion, the most prestigious fire protection engineering program in the country. And there's a lot of great things that happen here that impact everybody, and they don't know it's sitting right here.
Absolutely. So that beeping sound let us know we are now in the FPE labs. What makes WPI so unique with this type of research?
They have expertise and equipment that allows for fundamental research and applied research to be conducted from what I would consider to be the micro scale all the way to at scale. The research can start from what does it take for certain things to ignite, what's the chemistry involved, what are the extenuating factors in relation to the environment around that piece of material that they're looking into, trying to figure out how it ignites, how do they impact what happens, and scale it up to the point where they can move into the larger lab and test it utilizing, again, full-scale replicas of pieces of our environment. So trees, how do certain type of trees ignite and how does the fire spread from tree to tree, but also then look at how those fires that impact the built environment, which is some of the stuff that my research group has worked on in the past.
We're in part of the lab, I think they call it down here the smaller lab. Yeah. You can tell a lot of research is going on here. This piece looks like a hood over a stove.
Yep.
In the corner, it looks like it could be a hood that's over a grill area at a restaurant. Yep. Again, a lot of specific research in this area here, but let's take a walk into the big lab, the fire performance lab.
I can't emphasize enough the part that you mentioned in relation to be able to walk from the smaller lab, and I'm air quoting, right into the bigger lab. That proximity not only benefits certainly the research, but it benefits the researchers so that they can learn from one another and advance things at a more rapid pace. Yeah.
Talking about hoods over pieces of equipment, I'm not even going to guess the square footage here.
So this hood is crucially important to be able to establish the right kind of airflow through the facility, not only to make sure that the research that is being done is happening in a somewhat controlled fashion, but also to ensure the safety of the people that are completing the research. And it is impressive. It is big, it is tall, and it is unique.
If someone is interested in not just fire protection engineering, but civil, architectural, environmental, what does having a facility like this mean to a student?
Yeah, we're staring at a wall panel right now. The students being able to go into a facility such as this one and stare at something that is exactly what it looks like in their home or on a building or on a bridge is incredibly important. And being able then to participate in work that shows how these things perform at scale under various conditions and being a part of figuring out how to help things perform better ultimately so that we are protecting the public is incredibly fulfilling. Being able to do this is something, not only given the uniqueness of the facility, but the uniqueness of WPI and our ethos, and getting students engaged in exploring unanswered problems very early into their time here is something that nobody else really does as comprehensively as we do.
And embodies the hands-on project-based
Absolutely.
learning. So let's geek out for a minute as
Sure.
we're wrapping up.
I can't help but geek out.
When you were looking at WPI, really considering the job, were you super excited to be able to be in this lab?
Yeah, I've known about FPE for a long time, and having worked in this space to a certain extent, really focusing on what will the fire do to the structure that my group is investigating, really makes me respect this department. And when you couple that with, again, the project-based learning ethos of WPI and being able to get students involved throughout the process, throughout their matriculation, it's an incredibly unique place.
Your parting words on the excitement you feel being here for a relatively short amount of time, and the future of our researchers and our students.
Yeah. There's no place like WPI in the country, in my very biased and very honest opinion. And why am I saying that? Because we live the hands-on experience. We saw that in the environmental engineering lab that we visited, where two young men working with other students are trying to figure out how to clean up water and do it in a way that doesn't add to the waste that we have on the planet. Being able to observe that and experience that and have the students grow in that space and make fundamental contributions to many areas and see them grow as people and develop skills that are becoming more essential as AI becomes more prevalent. AI is a great tool, but there needs to be humans in the loop, and there needs to be groups of humans figuring out what to do with whatever AI produces. And that's what happens here. That's what happens with the hands-on. That's what happens with the creation of knowledge via tests, via building things, and then applying that knowledge to essential problems and figuring it out.
Yeah, very well said. I want to thank you for your time.
You bet.
And we can check in, I don't know, year and a half mark for
Sure.
a Dan with a plan.
Dan with the plan?
That'll be
All right.
part two.
All right.
This has been the WPI podcast. For more episodes, you can search for WPI Listen on the university's website, or look for them on Apple, Spotify, YouTube, or wherever you get your podcasts. Thanks again to Dan Linzell, and a big thanks to our audio engineer in the Global Lab, Varun Bhatt. I'm Colleen Wambach.